Physics is an interesting concept. It uses math to describe the world around us, and for whatever reason that nobody knows for sure, a system of rules we made up can accurately predict many natural phenomena. Let's take Newton's laws of motion. All three of them sound basic and boring. Of course, if I push something, it's gonna move. That is just common sense. But even so, that doesn't make these laws any less valuable. You need a platform to stand on in order to build up. It's like trying to build a skyscraper without a foundation entirely, or at least a very poorly made one. Leaning Tower Pizza. Sorry, I think I just had a coughing fit. What was it? Think about any object interacting with another one. With these three laws, you can perfectly describe their interaction. Hell, you could build a robot that can flip a coin and have it land on a desired outcome 100% of the time. In fact, we have done that. Okay, first law. An object at rest will remain at rest, and a body in motion will remain in motion unless it is acted upon by an external force. Again, something doesn't move unless you move it, and likewise, it doesn't stop unless you stop it. Here on Earth, if you move something, it will eventually stop. This is due to resistance forces. In space, where there is no air to slow things down, you push something, it just keeps going. You can experience this on Earth too, with air still present. You can just reduce the friction. One way to do this is to use a wheel. Another way would be to use a slippery surface, such as ice. In either scenario, it will eventually stop. However, you can tell just by a small push or a roll that the object will continue to move for a longer stretch of time than otherwise. Second law is the amount of acceleration of a body is proportional to the acting force and inversely proportional to the mass of the body. Now that is a lot of words, but all it is really describing is the simple equation, force equals mass times acceleration. All it means is the more mass something has, the more force is required to move it. It also means that the faster you want something to accelerate, the more force is required. If I want something to accelerate from 0 to 2 meters a second, it would require less force than from 0 to 20 meters a second. Also, if you wanted to use this to calculate resistance forces, you would use a negative acceleration. So, resistance force equals mass times negative acceleration. Negative acceleration can be interpreted as deceleration. Interestingly, if you make mass negative, it is equivalent to an object experiencing a buoyant force. So a balloon could be interpreted as having a negative mass, because it just floats away from the Earth. However, it is important to recognize that in truth, its mass is positive. It's just behaving analogous to an object with negative mass because of external forces, such as the buoyant force. This can be easily demonstrated. If you do the math, you can see that force equals negative mass times acceleration means if you induce a positive acceleration, it will move in the opposite direction of the force applied. And here is some footage I stole from the Action Lab. Great channel, by the way. Highly recommend it. The force being applied is coming from this string here, which is pulling the ball towards the center, and as you can see, the ball moves in the opposite direction of the force applied. Link to the rest of that video is in the description below if you want to see the rest of it. Link in the description below. Third law says that for every force there is an equal and opposite reaction. Now this one can be demonstrated rather easily, mainly because it is the main way how rockets work. They expel mass outwards, which then in turn pushes them in the opposite direction. You see, I have been trying to do something very similar by just throwing an uncountable amount of tennis balls down. However, I haven't been having much luck yet. And remember, if you want to go to space, just throw a bunch of tennis balls down. You might get there eventually.